Moves on a given straight line with a constant speed v. At a certain time, it is at a point P on its straight line path. O is a fixed point, so that OP cross P is independent of the position P. So first we have to draw the diagram. So this is O, this is P. Particle moves on a given straight line at a constant speed v. So particle moves at a speed v at a certain time instant point P. So OP is a fixed point, O is a fixed point, so this is the fixed point. So name this point as M. So OP, so suppose this is the vector OP. This makes an angle theta, this also makes an angle theta, so that OP cross V is independent of position P. So as this is OP, this is theta, so this facing angle is OP sin theta. As this is OP, this is theta, this facing component is OP sin theta. OP sin theta equals to how much? OP sin theta equals to OM. OM equals to how much? OM equals to OP sin theta. This is OP, this is theta, so this facing component is OP sin theta. So this is OP cross V. So this is OP cross V. OP cross V is OP sin theta. OP sin theta into V. OP sin theta into V. OP sin theta into V. OP sin theta is what? OP sin theta is OM. OP sin theta is OM. So this is OM into V. This is OM into V. OM into V. So this is 90 degree. So whatever be the position P, so this OM value remains constant. Whatever be the position of P, if P is at this point, this OM value remains constant. If P at this point, here also OM value remains, this OM value remains constant. If we shift the position of P, but this OM value remains constant, that's why OM into V. So OM into V, this is the final output, which is constant value. So that's why it is written as OP into V is independent of position P. So whatever be the position P, so this OM value is constant, that is OP sin theta. So that's why the final output is OM into V, which is constant value.